I feel like we can have this strange view of food sometimes. You can turn around any package and find a breakdown of all the ingredients, the macro and micronutrients, etc. But foods are actually quite different than the sum of their parts, which is obvious to anyone who cooks. But the way that the molecules interact and bond create not just a unique flavor profile, but a nutritional one as well. Introduce yourself and talk about your expertise.
Okay. So my name is Rosa Pérez-Gregorio. I'm working at the University of Vigo in Spain, in northwest of Spain. My main expertise is focused on the analysis of polyphenols that are a type of bioactive compounds with a specific regard on characterization in food and immunomodulation activities towards some immune reactions to food, mainly celiac disease, but also food allergies. In a more practical research line, we are performing new food products by using these polyphenols to enhance the functional and technological properties of the food. Mm-hmm. And this is more or less my main expertise.
Mm-hmm. So is your background more in like the chemistry side or in like the nutrition side? Or you
both
really
together. I mean, okay. we work from the molecules to the humans, so we need to first understand and know well the molecules, and then try to follow up all the process to perform the food, understand how these molecular changes are going to affect the nutritional impact when we consume these type of foods.
Mm-hmm. So what word should I be using for this conversation? I've heard molecules, compounds, chemicals. We're talking about these bioactive things in our food.
Yeah, I think that for me it's the same because okay. We used to use these different concepts. It's the same. So feel free to use whatever.
Mm-hmm. Okay, good. So my understanding is if I take a bite into any piece of fruit or vegetable, there's tens or maybe even hundreds of what we'd call these bioactive compounds, chemicals in that food. Can you just explain what that even means to get started? What does it mean for something in our food to be bioactive? How does it affect us? What does that mean?
Oh, well, I think that all food are bioactive because when you eat this food, the food has an activity in your body, okay? But we refer to bioactives to specific compounds that are not nutrients. I mean, when you eat something, you are going to use the nutrients mainly, but there are other compounds that are not nutrients, but have any effect in the metabolic activity of your body or any impact nor effect directly, and it's because of that there are named bioactives because they have any activity, biological activity. This biological activity is mainly related to health because most of them are antioxidants, or they have anti-inflammatory effects or any health-related effects, and it's because of that they are named bioactive, and it's important to eat some food products containing these type of compounds.
And we often study them for their positive effects. These can be negative effects as well. And I guess before we get started diving into the categories and things, trying to understand, I guess I want to make sure we understand what's the reason that they have this effect on our body. Like the plants they evolved these chemicals not for our sake, right? They evolved them for some reason for themselves, but then they have this effect on our bodies. So I guess why is that important, and why don't we just like denature them in our digestive system?
I think that the main point is that actually bioactive compounds are metabolized in plants because they are related with the immune system of plants. They act as defense compounds. there are secondary metabolites, okay, but they are mainly synthesized by plants after pathogen attack, for example, or to try to defend from mainly abiotic stressors. So the chemical characteristics are related with their action in the plants, and their action in the plants is directly interconnected with the action in our bodies. When we consume bioactive compounds, they can act by different mechanisms that were already studied through mainly in vitro studies. So the activity are mainly studied in isolated compounds, okay? And this is a little bit tricky because we can consider the whole activity we are going to have in our body after eat an apple, for example. It's not the same to eat an apple and correlate this effect with a specific compound isolated from the apple that consume all. Because in our body, these bioactive compounds are going to interact with all other compounds we are going to eat, and also with our digestive enzymes, for example, with our saliva, with our cells in the epithelium. So it's not clear actually how they works in a whole. We know that there are different mechanisms that can explain this effect, but actually, till now, we have not the evidences in a holistic approach, and we need it.
And that's really why I wanted to talk to somebody like you who has this expertise. Is in podcast world especially, you get tons of advertisements for nutritional supplements, different, isolated compounds that are anti-aging, anti-cancer, all these things. And I believe that, of course, these can have a strong effect on the body, many of these compounds, but I'm also, of course, very skeptical of the single one compound from the single plant in this one area that can have this dramatic effect on everyone's body.
I think that it's just the opposite. I
Okay.
mean, when you have an isolated compound, you can control. But when you have a compound introduced in a whole matrix, the matrix are going to have an impact on the activity of this compound that was studied isolated. In a food, you have proteins, you have lipids, you have carbohydrates, and they are going to molecularly bind to these bioactive compounds. So these are going to affect the bioaccessibility. So the amount of compound that are free to perform the effect, and also the bioavailability. So the amount of compound that are going to reach the lumen and the system. Also the activities related with a specific disease. Okay, but when you have the isolated compound in a supplement and you warrant that the pellicule are not going to be destroyed during the gastrointestinal tract and are going to reach intact to the intestine, you can control a little bit this bioactivity. Okay, but I prefer to recommend a diet more than eat a supplement. Because if we continue highlighting more evidences about nutritional recommendations and so on, able to maintain our health status and wellness, I think that is a little bit better because it's natural. And sometimes calculating the concentration need for each person is difficult because of the interindividual variability that is quite significant, the variation between one to each other. And also we need to consider not the variability on the specific amount on a specific compound, if also the metabotype. I mean, the type of metabolism I have. So it's a little bit tricky to use directly supplements without a specific precision approach. But it's not tricky to eat something that is healthy by their natural form. You understand?
Yeah, I tend to have that perspective as well. There's a famous one that I feel like fits in that category where wine, people always talk about the resveratrol in wine being this very effective anti-aging thing. And then they say, well, you can just do the supplement, but then on the other hand, the alcohol supposedly makes it more bioavailable. And there's all of these like back and forth of whether wine is good for you or bad for you, or that there's these trade-offs based on what's in it and the bioavailability and whether you take just the pieces or whether the whole thing is greater than the sum of its parts.
Yeah, because in our diets, in our daily journey, we eat a lot of different vegetables that contain different bioactive compounds that are going to have a different effects, and the design of the whole menu can affect the bioactivity because of synergies or even antagonisms we can have. Okay, so when you perform a clinical study and you give some specific food with a specific quantity to eat in a specific hour of the day, and you are controlling only this, but you have not the ability to control all things that you are going to eat, you are going to consume during your journey. And these are going to affect. So we need to change our minds a little bit and design novel strategies and novel tools able to give us some more realistic information.
Let's talk some specifics, I guess. What are some of the compounds that you study specifically? Just some of the common ones, some of the ones that we're most concerned with, most studied, things like that.
I work specifically with polyphenols. Polyphenols are a huge group of bioactive compounds. There are more than 8,000 different structures that have been already identified. I'm pretty sure that there are more than that. And they are divided into two main families, the flavonoids and the non-flavonoids compounds. And these are also divided into different groups. The most widely compounds in nature are the flavonoids. Among flavonoids, the anthocyanins are responsible for the red color and blue color of some fruits or the wine. And the flavonols are mainly present also in fruits and vegetables, but have not contribution with color. Some of them have yellow color, but they are not considered as pigments. Also, I have studied a lot the flavanthriols. The flavanthriols are a type of tannins that are present in the pellicles of some fruits and vegetables, and also in the seeds. I focus the research in these type of compounds because they are the major ones. They have a single structure, but this single structure are going to have multiple bindings to another chemical structures that make it diverse. I mean, this basic chemical structure can appear linked to sugars or fibers or whatever. They can form polymers. And there is a huge relationship between activity and structure relationship. Mainly because of that, I focus on that. And in the flavanthriols, I think that they are relevant mainly the polymers of flavanthriols because they reach intestine intact. They are not able to be digested. So they remain the activity intact also, and this is important.
You categorize them this way because they have a similar chemical structure, I suppose, but that doesn't mean that they all have a similar effect on the body, right? Just because they have the same structure, I suppose they have all different effects.
They have the basic structure, but if I put a sugar or another sugar, the activity are going to change. You have a lot of isomers, so the chemical structure is not the same, but it's quite similar, but the position of one specific group change and the bioactivity are going to change, because this is quite important in cells. I mean, if you have an hydroxyl group, for example, in a levo or dextro, you are going to have a different effect because cells are going to receive, so the receptors are quite sensitive to these minimum changes. And it's because of that is very, very difficult and challenging, this research. Actually, I have performed some study working on isomers regarding the inhibition of bioavailability of immunogenic proteins from wheat. We saw that the procyanidin B2 gallate has only for having the gallate in the levo or dextro linked. We have seen that you have significant blocking of the bioavailability or not, only for that. Or if we test the procyanidin B3 and B2, that's the only variation is to have 1 unit more than a polymer. The procyanidins are polymers, okay, from catechin or epicatechins that are the small units. And if you have only 1 unit more, you are going to have a significant different effect.
Okay, so I think I understand. So you have these bioactive compounds that we don't digest in the same way for calories, like a starch, sugar, those things, but they attach themselves in these structures, and that's how they sort of get in and interact with our body.
Yeah, when you consume these type of compounds, they are not going to hydrolyze to be digested in the same way that macronutrients. I mean, proteins are going to be cut by proteases, lipids by lipases and whatever, but polyphenols are not going to be hydrolyzed with a specific enzyme. Okay, and they are going to be degraded by mainly oxidation, but then they are going to be metabolized by different phase 1 and 2 type of metabolic stages. But the digestion is not compared to, has not been compared to proteins or other macronutrients.
Okay, let's do some food processing as well. We process most of our foods, at the very least. Even unprocessed foods like fruit, we still wait for them to ripen because that changes the whole chemical structures inside them. So we do other things, of course, like fermentation or cooking and things like that. So you just explain a little bit about how these processes affect and change the chemistry and make them more available to us to eat and better for us.
This is tricky because always processing means improve the bioaccessibility.
Oh, okay.
But not always affect positively the bioactivities. When you are going to buy fruit in the market, if you buy one or another, you're going to have different compounds because the food starts at the soil. I mean, the agricultural practices are going to affect the amount of compounds you are going to have into the fruit. So the nutritional value or the amount of bioactive compounds and at the end, the overall effect you're going to feel after eat something. But if we apart this, when we process a food in an industrial way or at home, we are going to change not only the whole structure of the cells, so favoring that these bioactive compounds that are inside cells can remain free and more bioaccessible for us. Okay, because some of them are linked to other nutrients in the plants. and they are not accessible for us because we are not able to digest properly. But if we're processing them, we are going to influence the structure, the microstructure of the food, and we can remain this food more bioaccessible. But we have another side of the coin, because during processing, we are going to also modulate or change the chemical structure. We not only open the structure of the food, we are going to also oxidize food. We are going to also put the food on degradation, on a type of degradation that can be not good when we think about bioactivity of the food. For example, if we are going to fry an onion, for example, the links between fiber and polyphenols can broke down, and the polyphenols became free. So in the raw onion, you cannot digest these bioactive compounds, but after frying, yes. But during this, the onion are going to suffer some other reactions that are going to also affect the pH, are going to affect the amount of reactive substances that are in this food, and this amount of different compounds can affect the redox balance of food. So at the end, you have an oxidation and a change of the structure, and this change of the structure can negatively affect the bioactivity, the antioxidant capacity, the anti-inflammatory capacity, the nutritional impact of consuming this food. And this is going to be affected by the conditions of the treatments, the temperature, the time, the type of additives. If you are going to use, for example, an olive oil that has also antioxidant, you can balance the reduction with the oxidation. There's a lot of different things that you can control and manage. I used to say that the best is to process the minimum you need. And try to eat like your grandmother eat. I think that is the best approach for us, is to don't process too much. I think that a minimal processing is needed, and it's good for us, but not an ultra processing, not adding a lot of different additives and ingredients we don't need to have a final food. And even at home.
Even at home, yeah. Of course, that's another buzzword that gets flown around in nutrition, of course, is the minimally processed or over-processed foods, right? And by that, they just mean like high temperatures. Yeah, I guess my point is like that it's more stable, but then that also means it's like doesn't have as many of these sort of chemicals in it that's reactive in our body, and that's what's important. Is that right? Or
the bioactive compounds are usually not stable to this.
okay.
And actually, it's a problem because phenolic compounds or polyphenols have some properties, technological properties that are able to enhance, for example, the emulsion capacity of gel, because all of these activities are related with the molecular structure. Okay, so there are free radicals, and because of their free radicals, they are unstable for nature. And this instability makes them highly reactive because they need to bind to something to become stable. And this binding, the resulting of this binding can be used for antioxidant and anti-inflammatory properties and to bind to cells and whatever, but also to bind to other compounds and in a technological point of view, making a structure on the food. Okay, but if during the processing you are going to alter this structure because they are highly reactive, you can break down the structure, you can break down the function, or change the function. For example, I think that one interesting group of compounds are the anthocyanins, because the anthocyanins have a tricky chemistry, because depending of the pH and the conditions, they became blue or red or yellow or without any color in the same food, only changing in a natural way because of the shelf life. It's not easy to use them in industry without alter the structure, because they are highly reactive. They degrade fast with temperature. I'm talking about flavonoids, okay? There are other structures that are more complex that remain stable. But when we talk about the major compounds, these major compounds are not stable.
Let's go back to the beginning a little bit, where some of these unique compounds, at least they're touted as having unique properties. Is that true, that there are just some truly unique compounds and their effect on us? Because we do see things like drugs, of course. It's like an obvious one. I wonder if that fits into this category, where I guess for an example, the resveratrol is like a very common one, or curcumin is another famous one that people talk about as being anti-cancer.
Yeah, I think that all activities related with resveratrol are quite good evidences. They are actually truly interesting compounds with
Okay.
power to be used, but not unique and not only. I mean,
Okay.
among scientists, we used to study the structures and the compounds that our colleagues are going to study also. So if we search in the literature that there are a lot of information about resveratrol, we start to study resveratrol, okay? And it's because of that we can have more information about resveratrol than other structures. But this not means that resveratrol is better. This means that resveratrol is more studied. But resveratrol actually has this potential. I don't think that these are overheaped. I think that this is real, but not only. And we need to also understand that every scientific study, every experimental procedure can have specific results depending on the environment, depending on the conditions you are going to test.
Let's continue there then. So when we're looking to the future and studying in your field, are there new techniques that people are using to try and study these things better? New technology that's enabling it? Give me a view for sort of like the way that your field is progressing in studying these compounds.
Okay, first of all, I think that the use of omics in the last 20 years have bring new insights on the whole effect of different structures, and not focusing only in only one. But this is only a first step. I think that there are a lot of things to do to understand the interpersonal variability, to design more sophisticated in vitro studies, able to give us more realistic understanding. The organoids have been used in recent years. The organoids are in vitro systems that mimic our organs. I mean, we are not talking about single cells. We are talking about more sophisticated cellular structures. But this is not the only tool we need. We need to start seeing the food as a whole, not as a sum of different parts. And if we want to understand if apple is good, I think that we need to analyze the apple, the whole apple, and not a quercetin, for example, that is a flavonoid found in apples alone. Use the quercetin alone extracted from apple but also compare with the whole apple and see, analyze, understand how the whole matrix effects are going to impact the nutritional quality, the health-related properties, and we need to also include not only the gut microbiota, but also our skin microbiota, our oral cavity microbiota, because when you eat something, you start at mouth. I think that there are not studies. We're starting right now to look at that. Imagine if we have some periodontal disease, a caries or something like that, our microbiota or our oral microbiota can change, and this change can affect the metabolization of our food. So we need to also include this microbiota in our studies, in our in vitro studies, to have a comprehensive view, and then include it into big data, and say also the pharmacology, the kinetics of the behavior, depending of our entire lifestyle, and not only focus on food, because our lifestyle are going to affect the metabolism, and the metabolism are going to affect how we are going to assume our food. And big data have the capacity, because it's so challenging. There are a lot of different factors affecting them, and we need to eat. We need to know how are we eating and what are we eating. It's important because the non-communicable diseases are increasing. We need to have information about how we can modulate this from home, from little changes. For example, polyphenols are able to bind mainly with proteins. If you eat a coffee with milk, the bioactive compounds in your coffee are not being bioaccessible in the same way than if you drink an American coffee. If you drink a tea with milk, it's the same. If you eat bread with some vegetables, it's not the same that you eat vegetables and then bread, because of these interactions. And I think that there are not information about that. I think that we need to perform more research on this, and more dissemination, more education at schools, starting from children, giving some information about how they need to eat.
Besides this holistic approach, is there any other questions, topics that you think are important for people in your field to study or to look into?
Yeah, I think that the safety, because we always talk about bioactive, good, but these compounds, when exceed a concentration, remains dangerous, or can remain dangerous for us, and it's because of that we need to take with careful the supplements use, because the supplements has not specific regulation, and every consumer can go to the supermarket and buy a supplement, and then at home eat food that has the same compound that they're going to eat through the supplement. And sometimes if you exceed a concentration, you can make some not adequate use of these compounds, because they remain unsafe.
I see. Yeah, that makes a lot of sense. So there's compounds that are good in certain doses, and then they tip to being toxic. There's probably some that are just have diminishing returns, right? I'm guessing these are still the minority, right, of compounds in plants. If you were to go out and eat random plants, I'm guessing most of the things in the plants are going to be bad for you, right? So, or even in a lot of the foods that we eat, I'm guessing there's some compounds in there that are just kind of inherently bad for us as well. Is that true?
Yeah, and the point is that all in a certain doses is okay, but if you exceed or took a low doses, you are not working in the right way. All antioxidants in a high doses became pro-oxidant. So if you're going to take resveratrol, for example, it's anti-aging in a specific dose. But if you exceed the dose, you are going to have pro-oxidant or aging.
So the kind of supplements that are not necessarily like isolated compounds, when people will eat a supplement of, I don't know, ginger or, something like that. Would you be more willing to recommend something like that or a whole food supplement than like the isolated compounds?
Yeah, totally.
Okay.
I'm not against supplements, but I think that you need to have information about what that are you eating. And if you have not information, if you have not an expert on food science, may the supplement that are you going to eat is not as good as you think. But if you took more complex substances, I mean mix teas and whatever, I think that in general is better because it's like in the middle of a supplement or a food. But if you have a specific disease and the doctor, for example, recommends you to take some supplement, for example, the red rice are being recommended for regulating the cholesterol levels in the blood. You can eat red rice, but you need to eat tons of red rice to obtain the effect. But in a supplement, you can have the amount of compounds need to have an effect in the cholesterol in your blood. But not by yourself, never by yourself.
Okay.
First ask and then buy and use.
So there's mixtures of teas or these supplements where they'll say immune booster or supports blood pressure, things like this. Are those generally true, do you think? Can you trust those, or you think that really is dependent on the person and whatever information they get from their doctor, something like that?
I think that most of them are true, but we have not information enough to warrant that the effects are going to be observed in all people. But in a large majority of people, the effect is observed. If you go for and you see clinical studies when a supplement is given to 100 or 200 people, the effects are there. But this not means that if you took this supplement, you are going to have the effect because of the
Especially,
statistics.
yeah, right, sure. And especially, I assume if you're already healthy, taking some immune booster for somebody who already has a good immune system probably doesn't do as much. Whereas, like, maybe on average, there's some people who need it.
And not only that, if I have horrible lifestyle, I do not practice exercise at all, I eat a lot of fats and whatever, and then I use a supplement because it's anti-aging, it's anti-inflammatory, are going to help me to control the obesity. Of course, you don't have any result
Okay.
because they are not magic. They are
Okay.
not therapeutic in the same way that medicine, a drug,
Okay.
but they help if you have a good lifestyle, a proper nutrition, and if you take these type of compounds with responsibility, it's okay.
Oh, that's interesting because I was almost thinking it would be the opposite of somebody who say they don't eat many fruits or vegetables in their diet and then they take this supplement. That's going to be much better for them than somebody who eats a well-balanced diet and is getting lots of these antioxidants and things anyway. Then maybe the supplements are kind of, unnecessary.
Yeah, and I understand your point, but I think that is not enough. If you
Okay.
take a supplement but you don't eat vegetables and your diet is not good, I think that it doesn't matter the amount of
Okay.
supplement you are going to eat.
Okay. Okay.
But on the opposite way, if you remain proper lifestyle and nutrition, you don't need the supplement. And if you exceed the amount of some compounds, and if you have not any pathology, any disease, maybe it's not necessary.
Do you have a favorite food that you think is particularly healthy for a lot of people? One that you like, or a particular compound either? I know people like coffee, wine, these sort of things. You have one that you think is really interesting or important to study or to take?
No, I don't believe in superfood. I
Okay.
believe in have a balanced diet. You need to eat fruit, vegetables, legumes, cereals, fish, whatever. Not exceed the amount of meat you're going to eat, or fish, or even vegetables. Okay, eat all in a balancing, and enjoy the meal. I think that other thing that is quite important, and we are starting to understand now, is how our mental condition when we eat affects the metabolism of and the bioactivity of this type of compounds.
Okay, just to throw another variable in.
Yeah,
Okay.
but it's important to
Wow.
enjoy our meal. It's important to be happy, to be in entire wellness and health.
Okay, great. I like that perspective a lot. We can end it there.